Okay, this is an example of exponential decay, and we're going to have to work just a little bit harder to actually come up with the decay function. We're told that the number of farms in the U.S. has declined continually since 1950, and in that year we had 5,650,000 farms, but by 2005 that had decreased to 2,100,900. We're going to assume we're following an exponential decay model, so I'm using an n here for number instead of a p for population. N of t equals n sub 0, the initial, times e to the minus kt, and it's a minus because it's a decay problem. We want to find the value of k and then write our exponential function describing the number of farms after time t in years, where t is the number of years since 1950. Okay, so t equals 0 is 1950, which makes the 5,650,000 the number in that year, n sub 0. And then it makes 2005 equivalent to t equals 55, right? Because it's 55 years from 1950 to 2005. And if that's 2005 is t equals 55, then n of 55 is this 2 million number. So 2,100,900 is equal to the initial population, or initial farms, 5,650,000 times e to the minus k times 55. Solving, we have an exponential equation here. So we have to isolate this exponential portion here by dividing through the coefficient. Now I'm not going to worry about simplifying too much on the left. If I can cross off a couple zeros, that's great, and then just leave it. Then we take the natural log of both sides. The reason we're doing that is because that means that I can apply the power rule and take this exponent and stick it out front and make it negative 55k times ln of e. But ln of e always simplifies to 1. So to solve for k, we just have to divide through by the negative 55. So we have the natural log of this big thing divided by negative 55. Now I want to show you on the calculator what that's going to look like. So ln of the 21009 divided by 56500. Now close that because we're done taking the natural log and divide that through by the negative 55. And we get our answer here of about 0.018 when we round. So let's just round a little bit, and this is going to be then our general decay function. Alright, now let's use it. How many farms would we expect to have in 2015? Well, we're given a t value here. T is going to be 2015 minus 1950 because that was our start year, our t equals 0. So we're going to need to use t equals 65. Plug that into our formula and just work it out. You should get 1,753,573. Now what about if we want to know when are we only going to have 1,000,000 farms left? If it's declining, when is it going to be that low? Well, they're telling me to find the t, and they're giving me the answer. So they're giving me the answer that I'm expecting for the n of t over here, and we're going to have to find that t. That means I'm going to have to solve another exponential equation. So we're again going to isolate by dividing out that coefficient in front of our e. This time we can cross off a few more zeros. Then we're going to take the natural log on both sides again, allow us to apply the power rule and bring the exponent out to the front, cancel the ln of e because that's 1, and then divide through by our negative 0.018 on both sides, and we get about 96. Well, it's not year 96, that means 96 added to our 1950 start year, so in the year 2046.